Today's episode of Spaceflight News will present a trio of captivating news from the space exploration. To begin, we will examine the first images of the asteroid Dinkinesh made by the United States Lucy spacecraft. Subsequently, we will discuss the triumphant flight of a propulsive landing technology demonstrator from the Chinese company iSpace. Lastly, we will focus on SpaceX, which has again achieved a milestone in reusability. Upon the launch of the US Lucy spacecraft into interplanetary space in October 2021, a clear timetable was established. In April 2025, it is scheduled to fly by the asteroid Donald Johanson, which orbits between Mars and Jupiter before proceeding to its primary targets, the Trojans of Jupiter. These asteroids, which follows the same orbital trajectory as Jupiter, but at a distance of 60 degrees in front of and behind the planet, are the main focus of the mission. However, during the spacecraft's journey, scientists made an intriguing discovery. Lucy was due to approach an asteroid, designated 152830 or 1999 VD57, which had yet to be officially named, at a distance of 63,000 kilometers this fall. After careful analysis, engineers determined that a minor maneuver could bring the spacecraft even closer to the asteroid. On the 24th of January this year, the updated plan was approved, and the asteroid, unofficially named Dinkinesh, became the first object to be visited by Lucy. On November 1st at 1654 Universal Time, Lucy approached the asteroid Dinkinesh at a mere 430 kilometers. The flyby, at a relative speed of 4.5 kilometers per second, was of paramount importance to engineers, as it enabled them to test a system that autonomously rotates the instrument platform during the flyby to precisely track the asteroid, which was less than a kilometer across. And this is the first image of Dinkinesh received from Lucy. It revealed a remarkable surprise. The asteroid Dinkinesh has a small moon orbiting it that had previously gone undetected. The image, taken by L-Lori camera just about a minute after maximum approach, showed the irregularly shaped main body, measuring approximately 790 meters on its longest axis, and the small moon measuring approximately 220 meters. This flyby provided scientists with valuable data for their research and enabled engineers to confirm that the system for autonomous pointing the instruments at a small target was functioning correctly. Therefore, the Lucy spacecraft can continue its unprecedented mission. On November 2nd, the Chinese company iSpace conducted a pivotal flight test. At the Jiuquan Satellite Launch Center, the engine of the technology demonstrator ignited at 6 o'clock Universal Time, and then took to the skies. The iSpace company already operates the small Hyperbola 1 launch vehicles, which can deliver approximately 300 kilograms of cargo into low Earth orbit. Nevertheless, the company was planning a new launch vehicle, Hyperbola 2, which was to be a two-stage rocket powered by liquid propellants, and most significantly, was to be reusable. The company later announced that it would bypass the Hyperbola 2 and proceed directly to the more powerful Hyperbola 3 launcher, which is also to be reusable. This technology demonstrator test we are looking at was designed to assess how the systems necessary for a powered landing function in practice. To add a bit more confusion to the names, this demonstrator has been given the designation Hyperbola 2Y, even though it is to be utilized to test the technology for Hyperbola 3. In a certain point of view, this demonstrator could be likened to the Grasshopper rocket that SpaceX employed to learn how to land the first stages of Falcon rockets. The iSpace company is planning the inaugural flight of the Hyperbola 3 launch vehicle for 2025. Nevertheless, the initial missions are not to include first-stage landing attempts. That should not occur until 2026 at the earliest. The 69-meter-tall Hyperbola 3, powered by liquid oxygen and methane, is anticipated to be able to deliver 8.5 tons of cargo into orbit in reusable mode. In disposable mode, its payload capacity will then increase to 13.5 tons. At 0:37 Universal Time on November 4th, SpaceX conducted another launch of the Falcon 9 rocket. The mission Starlink 6-26 was launched from the Space Launch Complex SLC-40 at Cape Canaveral in Florida.
And liftoff. Go Falcon, go Starlink. Vehicle is pitching downrange.
Are you under the impression that all Starlink missions are alike? Far from it. This launch was particularly exceptional as it pushed the boundaries of reusability. The first stage, designated B-1058, was utilized for the 18th time, setting a new record. This stage is the oldest in the SpaceX arsenal. It made its debut in May 2020, when it was used to launch the Crew Dragon spacecraft on its test flight. Apart from that, it delivered to orbit the Anasis 2 communication satellite, the Dragon 2 cargo spacecraft, or 2 shared small satellite missions. Most of all, however, it had been used to launch Starlink satellites. In total, it has been used 13 times for Starlink launches, including this mission. SpaceX closely monitors the condition of its first stages, particularly those that are pushing the boundaries. It is currently believed that a single stage can be used up to 20 times, though this number may be subject to change if the stages continue to perform well. B-1058 first stage did not disappoint even on landing, as it touched down without issue on the A Shortfall of Gravitas autonomous drone ship in the Atlantic. Thank you for your attention to today's episode of Spaceflight News. We are delighted in your interest in space news, and to ensure you do not miss future episodes, kindly consider subscribing to our channel. Additionally, you can find other interesting news on our profile on social network X, formerly known as Twitter. The link can be found in the video description.